Greetings. My name is Jacob Barhak. In a second, you will see James Bednar. I'm just going to introduce what we're going to do here today. So we're going to show you how to create presentations that are self-contained but still interactive. How to create static HTML files that you can open even on a computer that's not connected to the internet that hold interactive graphics inside. I do this to present presentations and create posters. Here's an example of an interactive poster as I've showed at the NIH, but it can be done to create interactive papers and some other things. Think about instead of papers being PDFs, being HTML files that you can do things. So the base technology for this is called HoloViz, and James Bednar creates this technology. He's the project manager in Anaconda that generates those tools. I'm a user, and without much ado, I'm going to move to James Bednar to start and give you an overview of
Hi, I'm Jim Bednar, and I'm here to tell you about some of the features of the HoloViz tools for visualization. And I run the HoloViz project. You'll see me online answering various questions. The actual work is done by a lot of other people, but I kind of coordinate everything and haven't helped to make sure all the libraries work well together. HoloViz is a project that we started here at Anaconda to try to coordinate between all these different libraries we've created in our group that each make some aspect of visualization in Python more powerful or easier to use. And today I'll focus on panel and HoloViews. If you want to learn more about the other projects, you can go to holoviz.org and learn about those. But here we'll focus actually on the HoloViews user guide. We'll look at the first page of the Getting Started guide, the introduction, and we'll look at the last page of the user guide. And so it'll kind of encapsulate what everything you can do with HoloViews. And part of what we cover is the panel library, but we won't look at the panel website today. So you can look at that for a lot more detail about how to build apps and dashboards in Python. But we'll focus on HoloViews, which is kind of a data-centric view, which is how do you capture and describe your data in a way that makes it easy to visualize, easy to make exploratory applications and exploratory analyses. So to dive right in, we'll be started with the introduction of the Getting Started guide in HoloViews, which is this Jupyter notebook here. And this notebook starts as any such notebook does by importing some Python libraries. And here we're using pandas, NumPy, and HoloViews. And HoloViews we'll call HV. And HoloViews, we're going to tell it to use Bokeh to do our plotting in this particular case. HoloViews is built on Bokeh, Matplotlib, and Plotly, and you can select which one you want to use to render your plots. It's a step above all of those libraries, and it lets you choose which library you want to use for a particular type of display you need or level of interactivity. Bokeh is particularly strong at interactivity, so that's what we'll use here. And so having loaded that and declared that we want both HoloViews and the Bokeh library, let's use pandas to load in some data. In this case, it's data about subway stations in New York City. And here that you can just see from the data, it's got the name of the station, the latitude and longitude location of the station when it was opened, how many services and what their names are offered at that station, and the ridership in millions for 2015. And so this is basically, this is just the data from the first 5 stations. There are lots of stations. And we'll use this as an example data set. It could be anything. I mean, really, it's just any columnar data set would work the same here. And so let's immediately just try to make something that we can see. And so here we're going to make a scatter plot, and we're going to use this station info data set. But you have to tell it a little more information than that, because if you just try to plot this data set, I mean, what do you want to plot? Do you want to plot the name? Do you want to plot the date it was open? Here we're going to say that we specifically want to see the services versus the ridership versus services. And so if you increase the number of services, does that seem correlated with the ridership? And if you look at this plot, it kind of does. There is an increasing ridership with services. And we've specifically said here, we've declared that it's a scatter plot, and on the x-axis, the independent variable will be services, the dependent variable will be ridership. And we call these independent variables, there's one in this case, but we call those key dimensions. And then for a given key dimension value, you can get a value dimension. So a given position on the key dimension will lead you a certain value on the value dimension. And so here we somewhat arbitrarily chose to plot services versus ridership. You could go the other way around. Here maybe the claim is that as you increase the number of services at a subway station, ridership goes up. But you could easily make the opposite claim, which is for the stations that have a lot of ridership, they tend to have a lot of services. I don't know which is the more reasonable way to approach New York City subway systems. I'm not in New York. I don't live in New York City. But this particular one is capturing the idea that we want to use this data and we want to show how services and ridership relate, and also the assumption that services is the independent variable. And all of that is bound up in this scatter object, and as you'll see, it shows up as a plot. But the scatter object is actually a data object. That's what allows it to be independent of whether it's plotted with bokeh or matplotlib or plotly. It's all it does is it's a very thin wrapper around your data, and it's showing that it's a scatter that will show services and ridership, and it actually shows the underlying, it stores the underlying data too. So scatter data will show you the original data, and so it's a capturing of this data plus the notion that services is your independent variable and ridership is your dependent variable for your scatter plot. That's what this scatter object has, but it happens to look like a plot, right? Well, it looks like a plot because when you return it as the value of your Jupyter cell, HoloViz sets up Jupyter's rich display so that how do you display this thing? What is this thing? Well, it happens to have a rich display that is a plot. But as you saw, it's actually not a plot, it's a data container. And so you can choose to display it as a plot, but you can do a lot of other stuff with it, as we'll see later in this talk. So let's immediately do some other stuff with it. First off, let's take it and then let's lay it out next to a histogram of, in this case, it's a histogram of when the stations were opened by date. And so a lot of them were opened at the initial creation of the subway stations, and then the rest followed later. And so here we have this histogram object, which again is a data object. And we've used this HoloViz operator plus, and that just means laid out next to each other. So we're showing the earlier scatter object laid out next to this other object. And again, if we look at that, we'll see that it's not just this multi-pane plot. It's a hierarchical data object where there are two items, and the first one is the scatter plot and the second one's a histogram. And we can actually pull out not just the, we can pull out the histogram itself, but then having pulled out that histogram, we can actually get at the underlying data if we need to. That's the data that underlies this histogram. And so even though we're able to display a multi-pane plot here, we always have access to our original data, and we can always keep going back to it and modifying it, selecting it, slicing it, whatever we need to do with the data. And so the idea is that a HoloViz container, unlike a plot, is not a dead end. It's not one particular image or display. It's a way of describing your data that looks like a plot, but you can go on from there and lay it out next to other things, put it together, do operations on the data. And you'll see some more operations here in a minute. But first, let's get some more data in here. This previous data was columnar data, so it tends to be fit to a table, a nice table format. Let's look at some data that's not table data, columnar data. Instead, this is multidimensional dense array data. In this case, it's showing you an array, essentially a 2D histogram by hour of taxi drop-offs. So for every, it's a kind of a heat map. Every pixel in Manhattan will show how many taxi drop-offs there were in that pixel. and it's stacked up by hour so that you have that data independently per hour. And so let's go ahead and plot that so you can see what I'm talking about. So here we created an HV image object. The previous one was an HV scatter object or an HV histogram. Here it's an HV image. And we'll pull out the data from midnight. So it's a whole stack by hour. We'll just pull out the first hour and plot that first. And that's what's shown here. We can show it in the previous. So that's this data image is this object. But of course, if we were to print it, we would see that it is not, in fact, a plot. It is, it's an image with the latitude, with the key dimensions. The independent dimensions are latitude and longitude, and then there's one dependent dimension, which is the Z or Z dimension here. That's the number of drop-offs in each pixel. It happens to be called Z in this case. And then we can go ahead and take this new data that we have, and now we can combine it with other data. Let's combine it with our station information from before and take overlay. We already covered the layout operator plus. There's an overlay operator star, and let's overlay the this image of taxi drop-offs with a set of points, which are the latitude and longitude locations of some station info from our previous data frame. And that's what's shown here. Each of the red dots is a location of a station, and it's overlaid on top of the taxi drop-off information. And so you can see that there's really no dead ends here. You can always just keep adding additional data for context or displaying data in different ways. And if we were to look at the underlying object here, it appears to be a layout of two things in an overlay, and you can see that's exactly what it is. It's a layout of one image and one overlay. The overlay consists of an image and some points, and you can always index into it, pull out the particular bits of data that are involved here. All right, and then, but notice that we only selected the data from midnight. HoloViews actually lets you handle arbitrarily more dimensions than you can display. Here we had to select midnight because we have latitude and longitude, and there's nothing to do with time in this plot. There's nowhere for time to go. We have one of these images per hour, but we don't have anything we can do with it. So what we can do with it actually is use a HoloViz concept called a HoloMap. A HoloMap lets you index data along dimensions that are not shown, and you end up, by default, you end up with a little widget. So here we have this additional data dimension called hour, and we didn't have anything, we haven't told it what to do with it in the plot. So we end up with this widget here, and we can now just select which of the values along that dimension we want. And so we can see that drop-offs go down until early morning hours, and then they go up as people go to work and so on. So we can easily explore this additional time dimension. Even though it's not present in the plot, it's present in the HoloMap object that comprises the plot as it exists across different values of this dimension. So this HoloMap has a key dimension of hour. That means that we're going to select an hour, and given that selected hour, then it can plot whatever's in the HoloMap, which is each of these is an image. For each hour, there's an associated image. So hopefully you can see from this how you can effortlessly explore larger dimensional data. In this case, there's one extra dimension. You can have as many dimensions as you wanted to. Each one would end up with a widget here. So you could explore a very large dimensional data set, map as much as you want onto the screen at any moment, and then the rest will end up being widgets. And of course, it's still not a plot. It's still a data object. In this case, a HoloMap indexed by hour of images that are indexed by latitude and longitude and show Z or drop-offs. And again, it's not a dead end. This thing with a widget, it's not, that's just how this displays. If we don't want it to display that way, we just do a little more work and we say, oh, we're going to pull out hours 3, 6, and 9, select those first, and then lay that out. And then now we have a plot with no widget because it's all been turned into a layout where three of the items are shown side by side, the rest have been discarded. And so again, we could print this and we could see that it's always a data structure, not a plot, but it displays as a plot. And so having gotten this HoloMap here, I keep saying this, but it's again, it's not a dead end. It's now something that we can overlay. Take the HoloMap. Now we can overlay some subset here of our stations. So we already we had them already defined as points. Now let's just select a subset of those, the ones that fall in this little box here, and then we'll take those and overlay them. Now again, we get a slider, and now it's a slider where everything you're showing at a slider value is not a single thing, but an overlay of points on top of the drop-offs. And we can see that if we pull out one of them, and we'll see that one thing that we at hour 7 is now an overlay of points on the plot. So you can see that we've kind of inverted things where even though we overlay all hotspots on top of the entire HoloMap, each one of the frames is now an overlay. That's essentially what overlaying a HoloMap means, is to create a frame of the HoloMap that is an overlay. And again, we can pull out the data from this object. And then that's about all we'll cover of HoloViews. HoloViews has a lot of different plotting types, a lot of different things they can display. Whatever you come up with, you can now export. If you have this part here with the widget, if you think about it, how this is actually done in the browser is a lot of bokeh JavaScript code to do this display and do these dynamic zooming and panning operations. That's all JavaScript code that's running in this HTML page, and so is this widget here. And so we can actually export that to a separate HTML file. And here we're rendering each of the frames of this HoloMap, and the result is a standalone HTML file. This particular one is just exported straight to my hard drive here, and you can see the widget still works, the zooming and panning still works. But we no longer rely on any Python. We used Python to create all of these objects and work with them interactively. But the result of it is just a HoloMap is just a static data container, and it's indexed by hour. And so we can apply the widget code to it and display the data that's selected by this widget. You don't need Python to do any of that. And so we can now email this to somebody, just put this HTML in our email, or we can put it on a web server or do whatever in an application. And so your final result and your final output can be shared very easily with people. And so there's one more topic to show, which is all of this is using HoloViews alone. What happens if we combine it with panel? And you'll see that we get a lot more flexibility. We can start with kind of the same things, and then we'll see where it goes after that. And so just a very brief introduction to using HoloViews together with panel. Here it's a slightly different example. This is the first introduction, the first bit of the getting started. Now we're the last bit of the user guide. And the user guide happens to use a different example here. In this case, this is a bunch of stocks. You can choose which particular stock you want, and whether you want to see its open price on that date, the volume of transactions on that date, or whatever. So you have various, again, you have various columns of data available. In this case about stocks. And so here we've used something that's very much like a HoloMap. It's actually called a dynamic map. And a dynamic map is the same as a HoloMap, but it can literally dynamically recompute every time you select one of these values. And so a HoloMap would have every combination of all of these widgets, whereas a dynamic map can, depending on what you select, a dynamic map will execute a callback function. So here, this is still just pure HoloViews, but it's a more a little more complicated example, and we're using a HoloViews dynamic map to take this callback function here, execute it depending on these two key dimensions, symbol and variable, and every time one of those values change, it'll rerun this function and select the data that you wanted out of that data frame. So otherwise, this is pretty similar to what we've been seeing before. But actually, in this case, here we're using a concept called a HoloViews operation. If we've taken this dynamic map, this could also have been a HoloMap, and then pass it to this operation called rolling. That actually takes takes the output of this curve here and runs it through a rolling window smoothing operation. So if we say we're to do that with a higher rolling window, you'll see that this has now become smooth. And so far this is all done in HoloViews, but what if we wanted to add an arbitrary widget here that controls this rolling window? That's where panel comes in. Panel is actually what HoloViews is using to create all these widgets, and that's all happening automatically behind the scenes. But you can do it explicitly, and so you can achieve whatever layouts and widgets you want and control your entire experience. And so that's what we're doing here. Here, let's use panel to create a few widgets. Here, one of the widgets is very much like this one that came for our HoloMap or dynamic map, which selects the symbol. One of them is for the variable. Just for grins, chose a different type of widget. So you can see here that instead of selecting it from a list, it's in radio buttons. But otherwise, it's the same action of selecting one out of this list. And then this is similar to the above. And then this is a slider that lets us choose our rolling window. So these are just generic widget objects provided by panel. And as you can see, they don't do anything yet. We just created 3 of them, put them in a panel column, and then you can display them. That's not very useful yet. So let's attach it now to our dynamic map that we set up earlier. And here we'll take those same widgets here and lay them out next to a plot that they're controlling. And now let's just see how that works. As we control our rolling window, you'll see our plot gets very smooth here. And this is what we were trying to do, is have an operation where we get a widget associated with it, and our HoloViews plot is now controlled by that widget by passing the value of that widget as to this rolling smoothing parameter. And again, we can choose each of our stock options, and I don't mean stock options, our available stocks, and then choose whether we want to plot the volume or the some other parameter of this data. And so how does that work? We take our dynamic map that we had above. That's the same object here that we were viewing with its default widgets. And now we're going to attach it to our very specific widgets that we created. Instead of relying on HoloViews to do the widgets, we're taking this symbol widget that we created, a variable widget we created, and the rolling window widget. And then we're specifically saying, panel, bind to the load symbol function that we had before. That was what was the callback of the dynamic map. If we take that and we're going to bind to the symbol argument, you're going to bind the symbol widget. So here's this symbol widget. And we're going to the variable argument, we're going to bind this variable widget, which is this variable widget we defined up here. You're going to take those and bind those to the argument to this load symbol function. And then that is what we're going to make our dynamic map from. And so here we're explicitly saying that don't let dynamic map have its own widgets. I'm going to bind these particular widgets to that dynamic map, to those values. And then we're going to take the result of that and feed it through our rolling window here. And again, we're going to bind this rolling window widget that we just created. We don't have to say pn.bind in this case because HoloView's operations already know how to deal with panel widgets. So you can just go ahead and pass the whole panel widget right there, and it automatically knows to connect that up. And then we show that as an app, and we make a row with a widget box in it. And the widget box should have a little bit of markdown text, and then three widgets, these three widgets, and then the result of this HoloViews operation, and then we can display all of that. And so there we made a little app. The app takes our HoloViews app object, this HoloViews dynamic map, and displays it depending on these widgets. And we can now, if we want to create a standalone application, here we do .show. We can also launch it separately from the command line. And then now we have a shareable application. This is a live running web server kind of application. This is one way to do things. You need to figure out how to deploy things if you do that. Another approach is just to go ahead and save the result and tell it to embed. And what this does, you can actually watch what it's doing. It's taking this app and it's trying out every combination of every variable and sampling it. So it's not trying all rolling windows, it's only trying by default 3 of them. So a rolling window of 1 and 183 and 365 looks like, something like that. And it's cycling through all the combinations of all of these different variables and then saving that to a static HTML file. And again, this static HTML file now that we saved here, it no longer depends on Python because it just pre-computed everything that was being done in Python. It was calling that Python callback for every combination of these values. And so the resulting app is usable and shareable and exportable. It's not actually dynamically calling anything. And if you were to try to sample it at every value of this rolling window, it would be you'd end up with a very large file. But in principle, you can design things so that you can either stand up a real Python-backed application and do anything you want in Python dynamically as you're dragging widgets, or you can take a subset of those things, design it well, and end up with a static HTML file that you can now share and archive, and that's the output of your little research project here. So basically, hopefully this shows you what you can do with HoloViz tools, specifically HoloViews and a little bit of panel, to make an interactive presentation of your data, both from the whole process of exploring your data to being able to share it as static HTML. If you want to follow up further, check out holoviz.org, holoviews.org, and panel.holoviz.org. That has all the details on everything, and you can download everything and try it out yourself.
Welcome back. James gave you an overview. What I'm going to do is I'm going to go and show you some practical things you can do with this technology. And the practical thing is creating presentations that are static files, static HTML files, but they are still interactive. The user can interact with the contents there. So this presentation itself is interactive. As you can see, the tabs here, I can switch. I'll show you later more interactive features. This is a static HTML file. And if you look, you can download this entire presentation, this file, using this QR code. I'm going to hold a second so people can take a picture of it and load it in their phones. Also, in this presentation, you will find a link to my GitHub account where I actually have this presentation and many others, as you can see, that are very much like it, that show examples of things you can do. So, how do you create a presentation like this? So, James gave you all the pieces. I'm going to go down a little bit further. So, one thing you do with presentations usually is you have to write text. I no longer create text in PowerPoint presentations, almost never now. I use this technology now because it's much richer with the things you can do with. So one of the basic things you can do is you can write text. Here, you use Markdown to generate text. You can generate plain text, But you can also generate text in different headings, italics, bold, and you can even generate links. This is all using Markdown, and the way you do it is panel.panel. The libraries panel is the object, and then you put in the text. This renders, as you can see in the right. In this presentation, I'll show you text code in the left and what happens to it in the right. Um, Plots. James showed you how many plots you can generate. I'm going to give an example of a simple plot. Uh, so here's a scatter plot, but this one I'm generating using the matplotlib backend. Notice the image is an image; it's not interactive. It actually looks a little bit skewed when I go and generate it. Um, at least the font looks kind of funny squeezed because it's an image. It's a file. It's a PNG file that is being used here. However, if you want crisper graphics and also interactivity like this, I suggest you use one of the other backends. So here, for example, I'm using the bokeh backend, and to get the interactivity, I'm using a hover tool. So basically, it's the same plot as above, but using a different type of elements. So notice you can do with HoloViews all sorts of graphic elements, bars, scatter plots. But the only thing you need to do to add interactivity is just add the words tools or equals hover, tools equals hover, and you can add this. You can also generate custom hover tools. I won't go into these, but there's tutorials online. If you want something a little bit more complex than simple text like equations or some very specific type setting, you can use LaTeX, and panel.pane.latex will allow you to create those uh, uh, texts you see here. And those are using two different backends, the Catic backend or the MathJax. Panel supports them both. If you don't want one syntax, you can switch to another. Or if there's one thing that one is better than the other, one backend is better than the other, you can use those. And you can generate different equations, as you can see here. And you can control things like font size, which you cannot really do easily with Markdown, especially not the equation ones. You can also create HTML content. And this is important to understand. You can add colors using HTML. And basically what we're doing is using the basic Markdown pane. When you say panel.panel, it basically tries to detect whatever you're plugging in, and it will understand this is Markdown. And however, Markdown does support HTML. So when you write HTML text like this with the tag of span, if using color, it will color things. You can also use things that are available in HTML that are not available in Markdown, like adding a hover tool over a link. And this is the example of how to do this here. When you go to this link, there's actually a hover tool, unlike the links I showed you before with Markdown. You can do more elaborate things, and I'm using here old code written using in Python to generate images and encode them in base64. Take an image, load it, encode it in base64, and show it using HTML. Now, why am I doing this elaborate thing? There are ways to present images in panel, so you don't need this. However, I'm showing you things that are possible to do, because when you write this text, you can now save this HTML where the image is part of the HTML itself. I will explain. The image is no longer a link. It is part of the file. Panel can do the same thing using other techniques, but I'm showing you that this is also possible to do using HTML alone. And when you do this, when you transport this file, the file will be bigger, but the image will not have to be loaded externally. Um, you can generate tables. Actually, there's more than one way to generate tables in Panel. One of them is just using Markdown. Markdown supports it, and you might want to add the CSS at the beginning because it will allow you to format how the table will look like. However, Markdown tables are not always the best way to go. They are very nice. However, if you need something nicer, you might want to go with the interactive tables that are provided by panel.pane.dataframe, and you can then uh, go over the table and actually do things with it, like highlight things. It also looks much nicer, much crisper, and you can control many more things. But since we're using a data frame, by default it will add the index. I suggest putting index equals small, so it will not show you the index column of the data frame when you actually show it as a data frame in panel. Now, let's start putting this all together. If I created images that have texts, images, or other entities that panel supports, now I can arrange those together. And the way to arrange them is to create the entities. Up until now, I created two texts, two texts and two figures. You can now take the two figures and put them in a row, just like you see here. Basically, panel.row and then the figures, and this is what will be generated. Then panel.column will do the same, only column-wise. Uh, Finally, you can mix those, and you can mix those in all sorts of ways because you can make rows of columns, columns of rows. So here, let's put the text that says scatter for the scatter plot, bars for the bar plot, and add them first such that each column has the scatter or the bar plot. So here I arranged the first column has scatter, the text, and then the figure. And then the other one is the text and the figure. Again, it's a bar plot. But then I make a row of columns, but you can also make columns of rows. Very, very simple. Each one of those, notice it's one line of code. But notice this entire thing here is actually a tab. The way I do it is a tab layout. So I go to panel and ask for a tab layout and just put in the text. The text here is the caption of the tab, the fig row, the fig column, the mix one, mix two. Those are the captions, and then the actual entities themselves of that I created before. And this is how you create this file. Now, let's say I want to save this entire tab example, and I want to save it as HTML. So the way you do it is, like James showed before, tabs.save, and then the file name. This will create this. Notice, very nice. It's the same tab I showed you before. Only what James didn't go into details is the fact that this file will not work in all conditions on all machines the same way, and it will not include all the information needed to render it. I'll explain. I'll show you the file, how small it is. It's about 58 kilobytes, very small. And also notice that the title, the caption is panel. If you want everything to be reproducible and the file to be self-containing and static, meaning you can give it to someone, send it by email, or give it to someone who doesn't have connection to the internet from their organization, and they can view it from inside the organization. The way to do it is through saving a little bit more complicated way, where you actually have to bring in the Boca resources. Basically, this is all the code that generates those images. We call it inline. And when you save, you first of all tell it the resources are the inline resources. This will ensure that you have all the code to run the Bokeh without needing to go out to the Bokeh server and download this. And then embed equals true. This forces all the images that are interactive that James showed before and I showed to be embedded inside. So this makes the entire file self-contained, and if you would add the title, then the title will appear, fully reproducible. Now, this file can be transported, and each modern browser should look at it, should be able to view it. However, notice the file is a little bit larger, 1 megabyte approximately in size. It's a small price to pay for reproducibility in my mind. Some people argue, so you choose whatever method is suited for you. The system supports them all, both. I will summarize and tell you that I've made many presentations with HoloViews technology, HoloViz technology using HoloViews and panel. And you can have some examples here. I've shown many posters. Now I'm generating actual interactive papers. And unfortunately, the publication system doesn't support it yet, but it probably will soon because I'm making a lot of noise about this. And you can download this entire presentation. It's self-containing with all the details you've seen inside, except from some of the links to the presentations that James showed before. And James has a very nice team that he's working with, and many of those people helped me a lot. They are very, very helpful. They have a GitHub channel. They have a discourse channel. I highly, I highly recommend that you try those. I will end the presentation now. Thank you for listening, and we'll be here to answer questions.